Thank you, Brad. As Brad mentioned, my name is Jason Koo. I am a developer advocate for Neo4j, a graph database company. And I will be talking about using large language models, because there's no way you're going to get away from Gen AI even here, using it to create a knowledge graph. Now, before I dive deep into what I'm going to present here, I would like to start off with a confession. And that confession is I have an amazing ability to forget pretty much everything. I am probably, maybe arguably, if Laura is not in here, arguably probably the person with the worst memory possible. I have managed to, in 20 feet, go from buying a movie ticket to losing that ticket before I got to the person that rips it. And then subsequently losing $20 more to get that movie ticket. Okay, so sample of chaos is if you can't remember anything. Okay, so I was super excited. Super excited when media works. If not, okay. So years ago. Oh, we'll just show everything at once. That's
screen do you want? This one?
Pay no attention to the elves behind the scene.
Mirroring everything.
Yeah.
Let's do not that one. This, I believe, is my presentation. Okay, yes. So a couple years ago, actually a lot of years ago now, there was a whole spate of like second brain apps that came out, right? Notion, Rome, and my favorite, Obsidian. And it was great, right? As a developer, I could write all my notes in Markdown, and then using just some special syntax, kind of link those documents together, right? So my favorite thing was this graph view, right? And I think I can actually show you my Obsidian. Right here. So this view is, I think, very awesome. Of course, how do I close this? All right, I'm not going to do all this too long. But anyways, you can see the sort of connection between your documents. And I thought this was great, right? It gives you a little bit of, not quite context, but like memory. Like, oh, okay, so I met this person at this event, and I also met this person at some other event. It started to help me like remember folks that I would run into a lot, or events that I went to, or places, right? So, question then, is this a knowledge graph inside Obsidian? Almost. It's not quite a knowledge graph, because those links between the documents they're kind of inferred relationships, but the relationship itself isn't explicitly defined, right? So I've got one doc that links to another doc, but what does that link mean, right? It's like looking at a crime board where you got, a victim and then a killer and then a place and a receipt, and they got that red line joining everything, right? You as an audience, you know what the red line means because the whole rest of the show was telling you what those connections are. This is a receipt from that store that connects the, whoever to the other person. So just like that, in Obsidian, those lines aren't explicit enough. So that's where knowledge graph is a little bit different, right? It takes those kind of unknown relationships and defines them, right? So like we here today, we make up a knowledge graph, right? We make up the structure of information, right? So I am here, I'm talking to you, you're listening to me. We are all as a group at a session that is itself a part of an abstract thing, right? PyTexas, which is located here at this public library, right? And you can map that all out in a knowledge graph. Now, why is that interesting? A knowledge graph gives you some extra abilities, right? It gives you context. So, okay, I'll come back to context. So, the links that go between us, they are basically like little invisible threads you can kind of pull on, right? So this kind of goes to the second part, the searchability, right? So Carol, well, she is from Encinitas. Encinitas is in San Diego County, or maybe just outside. It's in Southern California, very close to San Diego where I live. Great. Maybe there's a chance we have a circle of friends close together, but we're both here at PyTexas. We both like Python. So very likely, we've got a circle of friends that overlap pretty strongly, right? So that's something you can discover in a knowledge graph. Also, because knowledge graphs are inherently based on relationships and entities, it's very flexible. So you can iterate on knowledge graphs a lot. All right, so great. So you've got a structure for containing context and information. How does that help us as developers? What can store a knowledge graph? Graph databases are really good for storing knowledge graphs because the relationships that I've been talking about, that is part of the data store. So unlike some older databases where you have to temporarily create like a join, the relationship is explicitly stored as a first-class data component inside a graph database. And these are ranking, or this is a short list of available graph databases out in the market. Each has their own unique abilities, features, pros and cons. Neo4j, in particular, is a type of graph database known as a property graph database. What that means is the nodes, or the entities, they can contain properties, just like a row of data, but also the relationships can contain properties. So not just names, but you could put in time info, you could put in weights and values, right? So all of us, we all know Python, right? That's sort of a shared thing. But to what degree do we know Python, right? Like Ollie, I would say, is probably like, if we had to turn it into a float value, probably like a 0.99, maybe a 1.0, like all the way up at the top. And me, I'm probably more like a 0.01 maybe. So you can add these weights to a knowledge graph, to that data, right? And if you come from the machine learning background, you know that's very useful for lifting and creating ML models with. You can do that with data from a graph database, which is already in the form of what more or less looks like kind of a neural network. Okay, so other advantages of graph databases in general. No foreign keys. Like the relationship itself, because it is stored, it knows which two nodes it connects to. And often the nodes are written close together. So when the system is traversing through the relationships, it's going very fast, right? It's not a heavy lift to ask really deep many-to-many questions, which is kind of the third benefit, right? Which is because the information is interconnected, presumably, you can have a sparse graph where you're just putting in entities and they're not connected, in which case a graph database will not do you any favors. Use something else. But if you are using the relationships, great. And then, of course, it's very flexible, just like a knowledge graph. You can just add entities. You can add relationships. You can modify those relationships. So long as you are not destroying like relationships from old data, you can iterate. So you could create a whole data model, whole populated graph database, have a whole system of querying it, and then you're like, oh wait, I have a better way. I should create, instead of having 6 hops from like a vendor all the way to a customer, I just want to connect them directly. You can add that. And then all your new queries can take advantage of those new relationships. But your old queries will still work so long as you haven't destroyed those old relationships, right? So you could have basically many operating schemas on top of one graph system, one knowledge graph. Okay, I'm going to skip past this because as in all good fashion, LLMs, the testing did not work earlier, so I'm just going to skip and go right to talking about the main part of my talk, which is how do you get your existing data into a knowledge graph? Okay, so one option is to use large language models, which makes things quicker. And so the stack I'm going to talk about today is using LangChain to act as sort of this AI orchestrator. If you haven't played with GenAI yet, there are a couple tools like LangChain, Llama Index, that try to make it easier to work with different components. Right, so I'll demonstrate how that looks. And I'm going to use OpenAI because everyone uses OpenAI. GPT-4 is still one of the better models. And then I'll show how to push that into a Neo4j database. Okay, so I'll try to go through all 3 of these workflows so you get a sense of this. So we've got our data, which I'll talk about in a minute. And the manual process would be to just take that data, chunk it up, and have it fit into this data model that I've got in my head and put it into the database. The two LLM options with LangChain is kind of this three-step process. You're going to take a file, and you're going to put it into what is called a document loader. It is just a general object for LangChain for consuming, text data, basically. So it could be a YouTube transcript, could be a PDF, CSV, whatever. And when you put it into a document loader, it then becomes kind of this generic object that other parts of the chain can make use of. Okay, and then I got two options here. I'm going to use like a vector-only approach, and then also a new module that was added by LangChain called the Graph Transformer. So the Graph Transformer is a module that will take in this text document from the document loader and will attempt to break it up into entities and relationships. Okay. All right, the data I'm going to work with, or I'm just going to showcase, is a CSV of the agenda data that we have. So I used diffbot to take a first crack at kind of converting this into a CSV. Got kind of close. I had to manually kind of massage it. What I probably should have done was just ask the organizers for their copy of the CSV data. That's going to be easier, but I thought I'd give diffbot a try. And then the other piece of data is just a link to video, a YouTube video, which translates to a transcript of the video. Okay, so this is the part where everything breaks. Okay, if you can still hear me, excellent. Okay, so what I've got up and running here is I've got a local instance of Neo4j. And this is what the desktop looks like. You can basically spin up a bunch of databases, and here I spun up one for PyTexas. Oh, so it's an instance, and the instance itself has several databases, so I can toy with manual and LLM approaches. Okay, so I'm going to use the main database, pardon me, and just show you that it is empty. I hope it's empty. Okay, so no records. This is the empty database. And what I've done is I've built this really simple importer that is just a Streamlit app that lets me choose my target Neo4j database and then lets me select one of various experimental uploaders, right? All right, so the first thing I'm going to try is this graph simple approach. And I'm going to take the agenda CSV and put it in there. And that data looks like, where am I looking? All right, so it's just a CSV. I guess I don't really have to find it, but I really want to find it. Here it is, okay. Okay, so CSV, probably should open that in a Excel sheet. So it just has title, description, speaker, bio. And I'm just going to import that in. How the code looks is simple. So here I'm not using LangChain at all. So what I'm doing is taking the file that Streamlit has handed me and just going to throw it into a pandas read CSV function, and then just go through every row and basically pull out the row headers and values. So I'm going to turn that into properties. Well, actually not properties. I'm going to turn those into nodes, and then just push that into a Neo4j instance. So yeah, just reading the rows and then basically writing into Cypher. Cypher is the query language that Neo4j wrote to interface with graph databases. Interestingly, the ISO standard for interfacing with graph databases, right? So basically the ISO version of SQL came out yesterday, 2 days ago, so just recently. So now there's a standard for even modifying SQL or Postgres databases to be able to query graph systems, right? So there's a whole standard and spec. Now, their reference material was also Cypher, which is what I'm cobbling together here. So if you start with Cypher, there's going to be more material in Cypher than the new GQL, graph query language. which as a sidebar is not the same as GraphQL, which is the REST alternative, right? So the acronyms are both the same for both. And to make it more confusing, if you have worked with GraphQL is a good way to actually interface with data in a graph database if you're just pulling data. But yes, so anyways, two different languages. So I digress. If you start with Cypher, you will find the on-ramp to GQL not too difficult because they borrowed a lot from Cypher. So the two actually look quite similar. And because Neo4j was also on the or had a representative on the ISO board, anytime they decided like, hey, we're going to add this feature to GQL, Neo4j went like, okay, we're going to add that as well too, so that there's an interoperability that will happen. Okay, all right. Slightly forgot where we're going. Okay, so I'm just going to run this to show you what this looks like. Okay, so uploaded. At least I thought I uploaded. Oh, okay. So what I did is I uploaded it to the wrong database. I'll try this again. Oop. Let's see if that worked or not. Clearly I did not pay. Oh, all right. Never mind. Okay, so this is what that CSV looks like using this very manual process. Right. So I've got the document, the agenda CSV, and all the pieces. So basically what this did was it broke up each row and then decided from there like, okay, so basically made a node for each record. This in terms of knowledge graph is not really a great knowledge graph, but it shows you how you can quickly create one just from even a CSV file. You can do it from JSON, text, etc. Okay, now going back to here. Now, I'm going to show you the graph transformer. Oh, actually, let me show you yeah, I'll do graph transformer. We might skip the vector today. Okay, so the graph transformer. So this is LangChain's new fantastic module for automatically creating nodes and edges for you. Okay, so very similar function starting off, except this bit here. So part of Streamlit is for the CSV loader to work, it needs a path. So I can't just give the file. I had to basically temporarily create a location for the file just to get the path to then feed to the CSV document loader. So as you're working with LangChain and these sort of modules, be aware that they expect like very certain things, and it's not always well documented. So be open to experimenting a lot with this stuff. Okay, so here's the CSV loader, which is a LangChain component. It takes the CSV and it basically chunks up each of the rows and headers and properties. Now I take that loaded CSV and using OpenAI as the LLM, it's going to do some magic here and cut that up into what it thinks that CSV should turn into. And then I'm just going to add whatever it gives me into a Neo4j instance. Okay, so that's this guy. Oop. Start over. What I'm going to do is I'm going to reset this database so that it's blank. So this is what it looks like manually. I'm going to wipe this out and then reload this. And this one I'm just going to upload like I think 3 of the sessions, because every time I've tried to load the entire agenda, the LLM decides not to, quits somewhere along the way. Okay, so this is probably a little small for folks. So anyways, so this is an example of what Cypher looks like, right? So match is a common keyword versus select, and then maybe I'll showcase this later, but afterwards it's this sort of ASCII art syntax, right? So anything in a parens is a node, anything in a bracket is a relationship. In this case, I'm asking it to give me every single node that it's got, right? And actually, this looked pretty good, right? So we've got the CSV file, and it decided to break it up. Oh, right, for each row. So actually, this looks quite similar to the manual process. Oh, yeah? I think you're right. Yes. No wonder that I was like, wow, that looked really good. I never got that before. Okay. All right, try this again. All right, changes to transformer. And let it run. You'll also notice that anytime you add a large language model to any part of your process, the time takes much, much longer. Another reason, okay. So I had this problem earlier with the full file. Let me just, sometimes it will just work though. Oop. All right, I'm only going to give this one other try. Otherwise, I'll just kind of talk through it. Okay, I will talk through it instead. So what I have is, boop. So I'm going to switch to this other database, which I thought I had preloaded this prior. Okay, so this bit here was what the LLM had given me the last time I ran this. So you can see it created a bunch of nodes and relationships. A good chunk of it is connected, but you have these sort of like orphaned bits, and they're not connected to this at all, right? So you would normally think if we as a human were creating this, we would have at least one node that was, this is the source document, and tie everything together. But this graph transformer doesn't seem to be built to do that. So it'll just create a bunch of nodes. And so if you were to do this with a lot of files, you would probably come up with a really like DNA that's been broken up, just a lot of floaties floating around. So I'm glad that LangChain has started building this graph transformer, but as you can see, it's still very early on. So it's going to take a little work before this kind of competes with local stuff. All right, swing back. I guess while we're here, I have just a wee bit of time. Vectors. So the whole retrieval augmented generation RAG architecture has been created over the last year to help large language models deal with two main things. A, that they hallucinate a lot, and two, they have a limited context window. So if you are working on a project that requires some sort of permanent memory store for the large language model to compare against, vector databases have become kind of the mainstay, right, of what you would use. Now, you can use vectors with graph databases. So this is a great combination because vectors are fantastic with unstructured data, right? Like lots of text, it's like, okay, what's the feeling about a thing? Vectors are great at pulling that. But vectors are, unlike a lot of traditional databases, really terrible at math, right? So if you want to ask a vector database, hey, how many records do you have? It will just choose a number from any one of the documents it has. So unless somebody wrote a document that says how many files you've got in the database, it won't know. But a graph database and basically any other database can give you those answers, right? So sidebar, if you're working on a large language project, it's okay to mix and match different technologies. You will get much better results. Okay, all right. Okay, so that's my demo basically, since I think I kind of moderate results with the large language model. Yeah, I guess we could just jump right to questions, which I'm assuming people will have.
Off the first question, how does a graph database differ from a vector database?
Great question. Okay, so in a nutshell, vector databases take some data and turn it into a vector, or you take a vector embedding, which is basically a list of numbers, right? And you put that and you store it in kind of this vector space. So if you imagine, it's not quite accurate, but if you imagine a 3D box each embedding basically takes a dot, a point in that space. And when a vector database is asked to pull information, oftentimes you'll grab an embedding and try to find one that's similar to that. So, example, you have some text, it's turned into an embedding that represents the semantic meaning of that text. Then when you ask a question, that is turned into an embedding as well.
Okay.
And then those two are compared, and anything that's kind of close to the question embedding is pulled up, right? But each one of those dots, pieces of data in a vector database, they're independent. They're not linked, right? You can add in some metadata, but there is no relationship between different embeddings. But a graph database, it stores that relationship. So if you imagine it as a 3D space, it kind of looks not quite like a brain, but you can imagine like a branch, like a tree, very dense tree branch is what a graph database would kind of look like.
Yeah.
Hopefully that answers that question.
I got some of that.
Okay.
Okay. So the next question, I don't even understand the question, but I think you probably will. And hopefully the answer will make sense. So how do you avoid LLM hallucinations when adding or how do you avoid LLM hallucinations adding or removing data when entering into the database?
Okay. So whether you're using like SQL or a graph database, you can use text to SQL or text to Cypher modules. So what you're doing is you're not letting the LLM directly interact with your database. What you're doing is you're taking like a question and using the LLM to convert that into a query, right? And then you run the query against the database, the answer comes back, and then the LLM interprets that answer. So you can shield your database from being hopefully errantly like messed up. But yeah, that's generally the process.
I actually did understand that answer. That's helpful.
Right.
Awesome. Okay. Next one. Any best practices when building a knowledge graph database? Anything in particular to be aware of when you're building one specifically for LLM use?
Ooh, okay. So just in general, when you're building like a graph database or a knowledge graph, is you want to think about your data model, what it's going to look like at first. Mm-hmm. Don't fret that it has to be perfect. It's going to change. Everyone who works with knowledge graphs, it's constantly iterating. So you start with your best thing, and then you kind of import and work with that. When it comes to large language models, we haven't found anything specific yet that really gets great. Oh no, I take it back. So you want to have the relationships use words that are very common and make sense. So don't use relationship names that are very complicated. And if you have very complex paths between two entities that you always ask questions about, right? Like, hey, my ultimate question is, does this person like red shoes? But the path to finding out, maybe, they purchased this, that, and the other thing, they know this person. Just create a relationship between the two, and then you ask the LLM. Because the LLM also has difficulty in reasoning very complex paths.
Okay.
Even if you give an LLM the schema, I found that maybe only 60, 70% of the time, it actually looks at the schema and goes like, yes, I'm going to write a query that matches that. The other 40, 50% of the time, it's like, I'm just going to write up my own query sentence, and then it won't work at all.
Gotcha. So explicitly define that linkage relationship, and it can parse it more.
Yes.
Okay.
Yeah. So if you go and you kind of simplify things for it,
yeah,
it works.
That makes sense. So we're running a little bit ahead, so I'm going to ask one more question, and then we'll hand it off. Are relationships only extracted if made explicit in the document, or can it add implicit relationships known to the LLM that could be useful? So that kind of ties off what we're just talking about.
Yeah. So is the question asking,
are they only extracted if they're made explicit, or can it infer some of those? And that sounds kind of like where we were already. Yeah.
Yes. Yeah. So sometimes it can. I've not found it consistent.
Yeah.
It's just, it's kind of roll of the dice at the moment.
Fair enough. Okay. All right. Well, thank you so much.
Thank you, Brad.
Everyone. Jason.